um, about these relationships, and then really high level pulling that information back out. And so this works really well with the idea of a knowledge base and a rule set that we went over in. So you can see that Scheme really gives you all the pieces of an expert system, um, you know right here in your hands to work with. Um, you have your knowledge base right here, the set of rules that you define, um, that define the system. You have your working set, what are the facts that you know at any one time, and then you can infer from that, and basically that's what Scheme is. It's an inference engine. You can infer from that what you should do. So you can run queries on it and figure out whether or not a certain rule applies. So actually I want to show you kind of a JavaScript implementation of this. So here we have a set of rules. So our knowledge base, or sorry, not our knowledge base, but our rule set along with a series of knowledge base. So you have a knowledge base and you have your rule set. Kind of separated out here. So your different functions, how they relate to each other, followed by some data, or preceded by some data about them. And then you can run a query. So in this case, I want to know who is Tom a father of, right? And so I run my query, like processes, and I find out Tom is the father of Mary. Now I can do, add some other information in here, like let's say Tom's a busy guy and he has a couple kids. And alright. So now we can run that same query and find out that yes, Tom does indeed have 3 kids, Mary, Mike, and May. And now if we wanted to, very simply, we could add a new function in here saying sibling, like we had from Wikipedia. So if 2 people are siblings, then they need to have parent. They have to have the same parent. So the parent of X and the parent of Y must be that same variable, Z. So let's try that. And so now instead of father, we're going to do sibling. Let's just say who are the siblings of Mary. Or actually, you know what? I'll just run all possible siblings at this point. So you'll see that you don't have to just define any data. You can just leave it completely wide open in what you want to run. So let's see what we got. That didn't run. Why did that not run? Ah, I forgot a period here at the end. Now let's try it. So you can see that if I do that, I'll actually return that the sibling can be itself, which is not true, so I'd have to actually add some sort of test to make sure that X and Y aren't actually equal. But I can see that Mary and Mike are siblings, Mary and May are siblings, the recursive is true, and then May and Mike are siblings down here. So very quickly you can get very high level information out of this. And so once again, you could have a program like this interface with another program or another programming language, so that if you find out that there are siblings present, maybe 2 objects are related in your game, to fire off some new piece of code that will have them interact. So this can be very useful for your agent acting in intelligent ways. And so those are 2 different programming languages that I really want to focus on outside of C++ and Java. And so I'm going to send you guys some links. If you have some free time, you're not swamped with other classes, feel free to read up on these a little bit more. Play around with this JavaScript Prolog interpreter and get a feel for the language, and maybe one day you can find it useful in something that you're writing. So I'll see you guys next week for the review. Let's just look at our syllabus. So next week is the final project is, or sorry, final review happens, and the project is due. So once again, you guys have two different options. They're right here on the syllabus, a little further down, right here under project. If you guys have any questions, feel free to contact me. Homework number 9 is due by the end of the day, so please do submit that, and I'll post up the answers shortly. So talk to you guys soon. See you next week. In person in Science Building Room 137. Don't forget that. Talk to you later. Bye.